Hello everyone. In a previous class, we will discussed about the VI characteristics of the diode, like forward bias and reverse bias characteristics of the diode. So in this lecture, we will study about the classification of diode, means different type of diode we will study in this lecture, like Jenner diode. Inside it, we will study about the introduction of the diode, symbolic representation, and its working. Next is a vector diode, tunnel diode. So in this lecture, we will introduce firstly all the different type of diode, its definition, its symbolic representation, and its working diagram, as well as the characteristics of the different diodes. Now we will move the next topic is a pin diode, LED called as light emitting diode. Next is a photodiode, and further we will study about the Schottky diode. Next topic is a application of the diode in different areas, and finally the references of this presentation. So in this lecture we will discussed about the all the topic or all the different kinds of the diode. So let's start with introduction and classification. So in this lecture we will learn about the different type of diodes. These include the Jenner diode, LED, Schottky diode, tunnel diode, photodiode, etc. Now move on introduction. Diodes are electronic components, function as a one-way wall. The simple definition of the diode we will study in previous lecture. Diode is a two-terminal unidirectional uncontrolled device. Why it is called unidirectional? Because the current is flowing only the forward bias condition, and current does not flow in a reverse bias condition. So the diode is called the unidirectional device. Why it is called two terminal? Because it has two terminal, anode and cathode. Why it is called uncontrolled? Because it has only two terminals, so we can't control this device. Like as SCR or silicon control rectifier or thyristor, there is a third terminal is there, name is gate. So by using gate we can control the voltage, output voltage. But in case of the diode we can't control the voltage, so it is called the uncontrolled device. These diodes are manufactured by the semiconductor material germanium, silicon. The operation of the diode can be classified into two ways. If it is allow the current, then it is forward biased, otherwise it is reverse biased. Different type of diode have the different voltage requirements. For the silicon diode, for forward voltage is 0.7 volt, and for the germanium it is 0.3 volt. It means ये जो हमारा वोल्टेज है, इससे ज़्यादा जब हम वोल्टेज बढ़ाएंगे तो हमारा डायोड जो है वो करंट कंडक्शन करना स्टार्ट कर देगा. सिलिकॉन के लिए 0.7 वोल्ट होता है और जर्मेनियम के लिए 0.3 वोल्ट होता है. तो जब तक हम धीरे धीरे अगर वोल्टेज को बढ़ाएंगे 0.7 तक बढ़ाएंगे तो करंट हमारा बहुत ही इनिशियली बढ़ेगा, लेकिन जैसे ही 0.7 से ज़्यादा होगा तो हमारा करंट फ्लो होना स्टार्ट हो जाएगा. इन सिलिकॉन डायोड द डार्क बैंड इंडिकेट the cathode terminal and the other terminal is anode. तो अब जो फिजिकली डायोड देखेंगे एक छोटा सा सिलेंड्रिकल टाइप का होता है जिसमें 2 वायर्स निकले होते हैं, तो उसमें एक डार्क बैंड या डार्क लाइन बनी होती है। तो जो डार्क लाइन बनी होती है वो रिप्रेजेंट या इंडिकेट करता है कैथोड टर्मिनल को, और दूसरा फिर अगर वो मेरा कैथोड है तो दूसरा टर्मिनल जो है वो एनोड होगा। जनरली डायोड आर यूज्ड एज reverse polarity protector and transient protector. There are many types of the diode, and some of these are listed as follows. So the next is a Jenner diode. So first question is that what is the Jenner diode? So it is a passive element work under the principle of Jenner breakdown. Jenner breakdown we will study in a previous class जब हमने IV कैरेक्टरिस्टिक्स ऑफ द डायोड पढ़ा है, पीएन जंक्शन डायोड, उस टाइम पे हमने ब्रेकडाउन देखा था। तो उसी में जो ब्रेकडाउन वोल्टेज था रिवर्स वाइज में, उसी को जेनर ब्रेकडाउन भी हम बोलते हैं। फर्स्ट प्रोड्यूस्ड बाय क्लैंस जेनर इन 1934। जेनर डायोड को क्लैंस जेनर ने बनाया था 1934 में। इट इज सिमिलर टू द नॉर्मल डायोड इन अ फॉरवर्ड कंडीशन, and it is also allow the current in a reverse direction when the applied voltage reaches the breakdown voltage. देखिए नॉर्मल डायोड और जेनर डायोड में केवल इतना ही फर्क है कि फॉरवर्ड वाइज में तो दोनों के दोनों करंट बिल्कुल सेम ऑपरेशन होता है, बट इन अ रिवर्स वाइज पीएन जंक्शन डायोड डज नॉट अलाउ टू फ्लो द करंट, बट जेनर डायोड जो है उसमें करंट फ्लो होती है। कब होती है? जब अप्लाइड वोल्टेज ज़्यादा हो जाता है ब्रेकडाउन वोल्टेज से। When apply voltage reaches the breakdown voltage, तब करंट फ्लो होने लगता है जेनर डायोड में। उसी को हम जेनर ब्रेकडाउन कैरेक्टरिस्टिक्स में बोलते हैं, जो कि अभी हम नेक्स्ट देखेंगे। दिस इज अ सिंबॉलिक रिप्रेजेंटेशन ऑफ द जेनर डायोड. It is also a two-terminal device. Name is anode and cathode. It is designed to prevent the other semiconductor device from momentarily voltage pulse. It acts as a voltage regulator. तो जो जेनर डायोड है वो एज अ वोल्टेज रेगुलेटर की तरह एक्ट करता है। The Jenner diode is used to provide an output reference voltage that is stable despite change in input voltage. So this is again a symbol of the Jenner diode, is a clear symbol of Jenner diode used as a reference in a regulated power supply, and the Jenner diode is designed for operation in the reverse breakdown region. तो जेनर डायोड को हम इसलिए बनाते हैं क्योंकि ये रिवर्स ब्रेकडाउन रीजन में भी ऑपरेट होता है, वेयर द वोल्टेज रिमेन ऑलमोस्ट कांस्टेंट ओवर अ वाइड रेंज ऑफ द रिवर्स करंट वैल्यू. So now we will move the VI characteristics of the Jenner diode, illustrated the operation of Jenner diode compared to a rectifier diode or normally PN junction diode. The slope of the reverse breakdown region is exerted to show the detail. So the first diagram A is a IV characteristics of the normal operating region for the rectifier diode or PN junction diode, and the diagram B for the Jenner diode. So ब्रेकडाउन वाला जो कैरेक्टरिस्टिक्स है उसमें आप देख सकते हो कि जब हमारा ब्रेकडाउन जेनर ब्रेकडाउन VZ, नॉर्मली हम ब्रेकडाउन वोल्टेज को VBR डायग्राम में देखेंगे, VBR से रिप्रेजेंट करते हैं। V मतलब वोल्टेज होता है, BR मतलब ब्रेकडाउन वोल्टेज। तो यहाँ पे VBR को हम VZ से रिप्रेजेंट करते हैं, तो यहाँ पे VZ लिखा हुआ है। फॉरवर्ड का ऑपरेशन दोनों का सेम होता है फॉरवर्ड वाइज का, तो उस पर हम ध्यान नहीं दे रहे हैं, हम रिवर्स वाइज में काम कर रहे हैं। तो रिवर्स जो ब्रेकडाउन होगा उसके बाद अगर हम वोल्टेज को बढ़ाएंगे या रिवर्स ब्रेकडाउन होने के बाद अगर हमारा वोल्टेज को हम इंक्रीज करते हैं, तब हमारा डायोड जो है वो जेनर डायोड जो है वो करंट कंडक्ट करने लगता है। तो यही डिफरेंस है हमारा नॉर्मल डायोड में और जेनर डायोड में। इसी को हम बोलते हैं जेनर ब्रेकडाउन। VZ इज कॉल्ड द जेनर ब्रेकडाउन, और रिवर्स ब्रेकडाउन रीजन आपको इसमें शेडेड दिख रहा है डायग्राम नंबर 2 में। इसको हमने ऑलरेडी वीआई कैरेक्टर्स को हमने प्रीवियस वाले लेक्चर में स्टडी किया हुआ। The reverse characteristics of a Zener diode, VZ is called the Zener breakdown voltage, is usually specified at the Zener test current, जिसको हम बोलते हैं IZT, and it is designed VZT. तो डायग्राम में आप देख सकते हैं रिवर्स कैरेक्टरिस्टिक्स को डिटेल में बताया है फॉर जेनर डायोड का। इसमें जो हमारा आई जेड के होता है जिसको हम बोलते हैं जेनर नी करंट। नी करंट मीन्स जिसके बाद ब्रेकडाउन हमारा स्टार्ट हो जाएगा। आई जेड टी जेनर टेस्ट करंट। जेनर टेस्ट करंट में ही हमें जो वोल्टेज मिलता है उसके करस्पॉन्डिंग उसको हम जेनर वोल्टेज वी जेड से रिप्रेजेंट करते हैं। और फाइनली आई जेड एम इज अ जेनर मैक्सिमम करंट, जिसके बाद हमारा जेनर डायोड जो है वो रिवर्स वाइज में भी करंट कंडक्शन करना स्टार्ट करता है। सो दिस इज अ रिवर्स कैरेक्टरिस्टिक्स ऑफ द जेनर डायोड। So the Zener equivalent circuit. So in a diagram, the first diagram A, it's a ideal condition, means Zener diode act as a voltage source like VZ is called the Zener voltage. But in a practical Zener diode with voltage resistance is also connected in series. So this is the diagram or characteristics curve for the Zener diode in a reverse bias condition. So in case of Zener diode, we will focus on Zener voltage VZ or the Zener current IZ. This is the reason where the Zener diode is working in reverse bias condition. Now the next is a varactor diode. So these are also known as varigap diode. This is the another name of the varactor diode. It acts like the variable capacitor. जेनर डायोड जो था वो वोल्टेज रेगुलेटर की तरह एक्ट करता था। वैरेक्टर डायोड जो है वो वेरिएबल कैपेसिटर की तरह एक्ट करता है। ऑपरेशन आर परफॉर्म्ड mainly at reverse bias state only. These diodes are very famous due to its capability of changing the capacitance range within the circuit in the presence of constant voltage flow. So this is the symbol of the Zener diode. It is also a two-terminal device. Name is anode and cathode. They can able to vary capacitance up to high value. In varactor diode, by changing the reverse bias voltage, we can decrease or increase the depletion layer. These diodes have many applications as voltage control oscillator for cell phone, satellite, pre-filters, etc. The symbol of varactor diode shown in a figure. सो सिंपल लैंग्वेज में अगर हम समझें कि वैरेक्टर डायोड क्या होता है तो इसको वैरिकैप डायोड भी हम बोलते हैं और एक्ट करता है एज अ वेरिएबल कैपेसिटर की तरह। और ऑपरेशन जो है इसका वो मेनली परफॉर्म होता है रिवर्स बायस स्टेट में केवल, है ना। तो ये इसके कुछ इंपॉर्टेंट कैपेबिलिटी है जिसके थ्रू ये काफ़ी फेमस है और काफ़ी यूज होता है। A varactor diode utilizes the inherent capacitance of the depletion region of a reverse bias PN junction to vary capacitance by changing the reverse voltage. एक्चुअली हम रिवर्स वोल्टेज को चेंज करके कैपेसिटेंस की वैल्यू को चेंज कर सकते हैं। The P and N region are conductive and act as a capacitor plate. The depletion layer created by the reverse bias act as a capacitor dielectric because it is non-conductive. As the reverse bias increase, the depletion region widen and the capacitance across the diode decrease. As the reverse bias decrease, the depletion region narrow and the capacitance across the diode is increase. बहुत ही सिंपल है. जब हम रिवर्स बाइस को डिक्रीज करते हैं तो जो रीजन होता है डिप्लीशन वो कम हो जाता है, पतला हो जाता है, जिसके कारण जो है कैपेसिटेंस जो है डायोड का वो बढ़ जाता है. अगर हम रिवर्स बाइस को इंक्रीज करेंगे तो डिप्लीशन रीजन वाइडर हो जाएगा, बड़ा होता जाएगा, और इस कंडीशन में जो हमारा कैपेसिटेंस ऑफ द डायोड है वो डिक्रीज होगा. So the reverse bias varactor diode act as a variable capacitor. This is the diagram of varactor diode, similar just as a p-n junction diode. Varactor diode capacitance varies with the reverse voltage. This is the important point कि जैसे हम reverse voltage को change करेंगे तो डायोड का जो capacitance है वो change होता है. So this is a graph of the diode. Capacitance varies versus reverse voltage. तो हम डायग्राम में देख सकते हैं कि जैसे हमने x एक्सिस पे वोल्टेज रिवर्स वोल्टेज को कंसीडर किया है फिगर नंबर सी में, और वर्टिकल एक्सिस पे हमने डायोड कैपेसिटेंस को लिया हुआ है पिकोफैरेड में. तो डायग्राम में आप देख सकते हैं जैसे जैसे हम रिवर्स वोल्टेज को इंक्रीज करते जाते हैं वैसे वैसे हमारा कैपेसिटेंस जो है वो कम होता जा रहा है, डिक्रीज होता जा रहा है. सो हम सीधा लिख सकते हैं व्हेन द रिवर्स वोल्टेज इंक्रीज देन द कैपेसिटेंस ऑफ द डायोड इज डिक्रीज. और स्टार्टिंग में डायग्राम ए और डायग्राम बी में आप देख सकते हैं रिवर्स बाइस को हम ग्रेटर रखेंगे, ग्रेटर वाला डायग्राम, व्हेन पी कनेक्टेड टू नेगेटिव. दूसरा वाला जो है जिसमें हमें लेस रिवर्स बाइस और ग्रेटर कैपेसिटेंस मिलेगा उसमें भी हमें पी को कनेक्ट करना है नेगेटिव से. तो ये है हमारा नॉर्मली ग्राफ ऑफ द डायोड कैपेसिटेंस वर्सेस रिवर्स वोल्टेज. This is a symbolic representation and the equivalent circuit of the varactor diode. Now we will move the application of the varactor diode. So this is used for voltage control capacitor, as a voltage control oscillator, parametric amplifier, or frequency multiplexer. So these are the application of varactor diode. Also used in FM transmitter and phase lock loop in radio, television set and cellular telephone. The next topic is a tunnel diode. So what is it? A tunnel diode is a heavily doped p-n junction diode. The tunnel diode show negative resistance when the voltage value increase. Current flow decrease. The tunnel diode work based on tunnel effect. तो ये जो टनल डायोड होता है इसको हम टनल क्यों बोलते हैं? क्योंकि ये टनल इफेक्ट पे काम करता है. अब ये टनल इफेक्ट क्या होता है हम देखते हैं अभी. This is a diagram for the tunnel diode and symbolic representation of the tunnel diode. Leo Askey invented tunnel diode in August 1957. Therefore, it is also called the Askey diode. The materials used for the diode are germanium, gallium arsenide, and other silicon material. Tunnel diode show a negative resistance in their operating range. So this is an important point regarding tunnel diode. Tunnel diode show a negative resistance in their operating range. Now we will move the tunneling effect. In electronics, tunneling is known as direct flow of electron across the small depletion region from N-side conduction band into a P-side balance band. तो टनलिंग का सिंपल सा मतलब होता है इलेक्ट्रॉन का जो फ्लो हो रहा है अक्रॉस द डिप्लेशन रीजन में एन साइड की कंडक्शन बैंड से पी साइड की बैलेंस बैंड को, उसको हम टनलिंग इफेक्ट बोलते हैं इन इलेक्ट्रॉनिक. In a PN junction diode, both positive and negative ions from the depletion region. Due to these ions, inbuilt electric potential or electric field is present in the depletion region. This electric field gives an electric force to the opposite direction of externally applied voltage. So this is the diagram. By using this, we will explain the tunneling effect, where EC is conduction band, EG is called energy gap, and EV is called the valence band. So electron cross the barrier. Because its size is small, hole does not move or does not cross the barrier. Electron with energy greater than the potential barrier, so move on the another band. In this diagram, show this thing. As the width of the depletion layer reduced, the charge carrier can easily cross the junction. Charge carrier do not need any form of kinetic energy to move across the junction. Instead, carriers punch through junction. This effect is called the tunneling, and hence the diode is called the tunnel diode. And this is the diagram for the tunneling effect or tunnel diode. Due to tunneling, when the value of forward voltage is low, the value of forward current generated will be high. It can be operated in forward biased as well as in reverse biased. Due to high doping, it can be operated into reverse biased. Due to the reduction in a barrier potential, the value of reverse breakdown voltage also reduced. It reaches a value of 0. Due to this, small reverse voltage lead to the diode breakdown. Hence, this creates negative resistance region. So this is the diagram for tunneling or tunnel diode. Now we will move the VI characteristics of the tunnel diode. Due to the forward biasing, because of heavily doping conduction happen in the diode, the maximum current that the diode reaches is IP. You can see the diagram, and the voltage applied is VP. The current value decreases when more amount of the voltage is applied. हम कैरेक्टरिस्टिक्स में बहुत ही सिंपल तरीके से देख सकते हैं. जैसे हम वोल्टेज को इंक्रीज कर रहे हैं या वोल्टेज को हम बढ़ा रहे हैं, तो स्टार्टिंग में क्या होगा, जो है वो करंट इंक्रीज होगा, और फिर पीक पॉइंट आने के बाद जैसे ही हम वोल्टेज को फॉरवर्ड वाइज वोल्टेज को बढ़ाएंगे तो हमारा करंट जो है वो कम होने लगेगा, जिसको हम नेगेटिव रेजिस्टेंस रीजन बोलते हैं. तो रेड कलर से जो आपको दिख रहा है वो करंट है, हॉरिजॉन्टल एक्सिस पे वोल्टेज लिया हुआ है और वर्टिकल एक्सिस पे हमने करंट को लिया हुआ है मिली एम्पियर में. When the more amount of the voltage is applied, then current keeps decreasing until it reaches a minimal value. The small minimum value of the current is IV. From the above graph, it is seen that from the point A and B, current reduced when the voltage increased. That is the negative resistance region of the diode. In this region, tunnel diode produce power instead of absorbing it. Now the applications of the tunnel diode. So tunnel diode can be used as a switch, amplifier and oscillator. Since it shows a fast response, it is used as high frequency components. Tunnel diode act as logic memory storage device, and they are used in oscillator circuit and in FM receiver since it is a low current device and it is not used more. The next topic is a pin diode. So pin diode is the improved version of the normal PN junction diode and gives the pin diode. In pin diode, doping is not necessary. The intrinsic materials means the material which has no charge carrier is inserted between the P and N region, which increase the area of depletion layer. This is a symbolic representation of pin diode. It is also a two-terminal device, name is anode and cathode. When we applied forward bias voltage, the holes and electrons will pushed into the intrinsic layer. At some point, due to this high injection level, the electric field will be conduct through the intrinsic material also. This field made the carriers to flow from two regions. The symbolic representation of the pin diode is shown in figure. Now the next is a light emitting diode or short in LED. So light emitting diode, these diode convert the electrical energy into the light energy. So it is called the light emitting diode or in short in LED. First production start in 1968. It undergoes electroluminescence process in which holes and electrons are recombined to produce the energy in the form of light in forward bias conduction. This is a symbolic representation of light emitting diode. Earlier they used in inductor lamp, but now in recent application they are using in environmental and task handling, mostly used in the application like aviation lighting, traffic signals and camera flashes. So light emitting diode, when the device is forward biased, electron cross the p-n junction from n-type material and recombine with the hole in a p-type material. Since the electron in conduction band are at the higher energy level than the holes in a valence band, when recombinations take place, the energy is released in the form of heat and light. A large exposed surface on the one layer of the LED permit the photon to be emitted as a light termed as electroluminescence. This is the working diagram of the light emitting diode and the symbolic representation of the light emitting diode. Light emitting diode always have a current limiting resistor in a LED circuit, usually 1K to 2K ohms. So diagram number A is a forward bias operation of the light emitting diode, and second is a typical light output versus forward current, and some physical symbols of the light emitting diode. In characteristics, it's a linear characteristics, means if we increase the current, so the radiated light is also increased. Barrier potential VV is equal to 1.0 volt to 2.0 volt. Next one is a photodiode. A photodiode is operated in reverse bias. They typically have a small window to let light in. So this is the diagram of the photodiode. Number A, reverse bias operation of the diode. Number B, typical devices, and number C, alternate symbols of the photodiode. General graph of the reverse current versus irradiance for a photodiode is so below. A photodiode's reverse current increase with exposure to light. A photodiode circuit used in a system that count objects as they pass on the conveyor belt. So this is the example of the photodiode. कन्वेयर बेल्ट में हम फोटोडायोड को लगाते हैं तो कन्वेयर बेल्ट से जो भी ऑब्जेक्ट पास होते हैं उसको ये काउंट करता है. नेक्स्ट इज अ शॉटकी डायोड. Schottky diode is a device which comes under a type of metal semiconductor junction diode. Barrier diode and low voltage diode are the other name for the Schottky diode. When compared to a PN junction diode, the power drop is lower in Schottky diode. A scientist named Walter H. Schottky first discovered the Schottky diode. This is a typical diagram of the Schottky diode. Generally in PN junction device, when positive type P type and the negative type N type are joined together, they form a PN junction. However, in the Schottky diode, material like aluminum or platinum are used instead of P type semiconductor. So this is a normal PN diode, P type and N type material, and another is a Schottky diode, metal plus N type material. And second is a symbolic representation of Schottky diode. Now the working of Schottky diode, the most important physical parameter of this diode is there the fast switching rate and less forward voltage drop. It is a metal semiconductor junction that does not have the capacity to store charge at their junction. The reason behind this is due to absence of depletion layer. Usually a voltage drop happens across the diode terminal when the current flow through a diode. The Schottky diode voltage drop is usually between 0.15 and 0.45 volt when compared to the normal diode. A normal PN junction diode has the voltage drop ranging between the 0.6 to 1.7 volt. For a better efficiency and output, the voltage drop should be low. When manufacturing the diode, N-type semiconductor act as a cathode and the metal side act as a anode of the Schottky diode. When the voltage is given to the diode, the current flow in the forward direction. When the current flow through the diode, there will be minimum voltage loss across the terminal of the diode. This loss of the voltage is called the voltage drop. Next, we will move on the VI characteristics of Schottky diode. The VI characteristics of the Schottky diode is shown in below figure. Along the graph, the vertical line signifies the current flow and the horizontal line denotes the voltage applied across the Schottky diode. The VI characteristics of the Schottky diode is almost similar to the PN junction diode. You can see the diagram. Nevertheless, the forward voltage drop of the Schottky diode is very low when compared to the PN junction diode. The forward voltage drop range from 0.3 volt to 0.5 volt. The barrier of the forward voltage drop is made of silicon. The forward voltage drop is proportional to the doping concentration of N-type semiconductor. Due to high concentration of current carrier, the VI characteristics of Schottky diode is steeper. The application of the Schottky diode are used in electronic industries for many applications in a diode rectifier because of its properties. They are used the voltage clamping application to prevent transistor saturation. It is used as a Schottky TTL in a digital device as these devices require fast switching. as the performance of the digital computer is determined by the switching speed of the diode. The Schottky diode is an important component for the digital computer. The next topic is the application of the diode. So the following are the application where the diode is used. Diode used as a rectifier. It is used as a clamping circuit, used as a clipping circuit, as a logic circuit, and as a reverse current protection. So these are some application of the diode. Next lecture we will move on the detail analysis of these application. And we will move on the reference. So, and thanks for watching the video.